Alright, so now that we've figured out how to log our user in using both sessions and cookies, there's one more thing that we need to understand before we make our first website using a login system, our secret diary project, and that is how to store users' passwords securely. Now this is quite a complex topic, and what I'm going to tell you here is definitely not everything that there is to know about website security, but it's everything you need to get your users' passwords as secure as they can be. So let's first off see how we're doing things at the moment and realize why that's such a bad idea. So at the moment in our system, our password is just stored as plain text. So that's perfectly fine from a user's point of view. We can just log them in, test their password against the one that they've entered, and we'll get them in. But if someone gets access to our database, then obviously they can just access all of our user accounts. That's pretty bad, but it's even worse that most people use the same password for a number of different websites. So not only could they access your user's account on your website, but they might well be able to access their PayPal, their Twitter account, and many worse websites besides. So we need to encrypt the password in some way. But that encryption has to work in such a way that when the user enters their password, we can still test what they've entered against the encryption that we have stored. So there is a process designed specifically for this, and this is known as creating a hash for a particular string. And there's one well-established type of hash that we normally use in PHP, and that is MD5. And the MD5 function essentially takes a string. So let's say our user has a very bad password and does a one-way encryption on it. So it essentially turns it into a long alphanumeric string that is very hard to reverse encrypt. But given the initial string, it's the same output every time. So if we stored this in our database, then when the user tried to log in, we could MD5 it and then check that against our database, and we would then know that the user had the password correct. So this is known as one-way encryption because it's easy to go one way, and this result is unique for that word, but it's hard to go the other way. So you might think we're done, right? We can just store the MD5 hash of our users' passwords in our database and no one can go the other way. Unfortunately not. Because the MD5 string is unique to each original string, hackers can quite easily create long lists of MD5s for commonly used passwords. And you can actually check this for yourself online using a website such as crackstation.net. So if we take our long string here, paste it into crackstation.net, put in the captcha, then it will check that hash against its known hashes, and you can see it's got the password straight away. So that's the problem. Because this is a unique one-way hash, common passwords will be detectable by your hackers, and we don't want that. Note that if we do have a properly complex password, something like that, and I then save that and apply MD5 to that, then this will be secure. So anyone who has a good password in your database, will still be secured with this method because it won't be on a pre-created list. But that's not good enough for us. We want even the people who have weak passwords to be able to feel secure with our system. So how are we going to achieve that? Well, you could think of this as level 2 encryption. It's definitely better than not encrypting at all, but it's not the best we can do. So how might we get to level 3? Well, level 3 encryption adds something known as a salt. And that is essentially a long string of usually numbers and letters, but it could contain anything, which then we put in front of the password each time. And what we're effectively doing there is turning a weak password into a strong one. And then, if we see what the MD5 result of that is, and we attempt to crack that, it should fail. There we go. So this is pretty good and definitely better than level 2, but we're not quite there yet, because especially if you've got a large number of users, then it's possible for the hacker to get hold of that salt somehow and then work out the MD5s for that salt and commonly used passwords, and that would still enable them to decrypt the commonly used passwords. So what's our final top level 4 encryption? Well, what we do is we have a different salt for every item in the database. And that's actually quite easy to create. We can use something like the ID for that particular row. So let's imagine that we've got a row ID of 73. We can then MD5 the row ID and use that as a salt. And then because we've got a different salt for every user in our database, it's still not 100% impossible for the hacker to get hold of one of the salts. But if they do, that doesn't give them access to any of the other passwords, and they have to start from scratch with each user. So essentially, it will be such a long and complicated process that it's probably not worth it for the hacker to try and decode even commonly used passwords if you do it this way. The other advantage of doing it this way is that you don't even need to store your hash anywhere, because it's just calculated from something in your database. One extra point to bear in mind is that you should make sure that you use something absolutely static for your variable salt here, that is static per user. So don't use the user's email address, for example, because they might change their email address. And if they do, then your hashing system will break, or at least you'll have to update the password with the new hash with a new email address. So better to use something absolutely fixed, like the ID number. So there we go. This is our secure as we can possibly manage way of storing passwords. And we're now ready to build our complete login system for our secret diary website. We'll do that in the next video.